Welcome to today's video. What are fluids, what is pressure, and how do they relate to physics? To begin our video, let's first take a look at these two pictures. Right, we have a water-filled balloon and we have an air-filled balloon. It could be helium, it could just be a mixture of air. But what are the similarities and differences? Right, first similarity, they're both in balloons. Okay, I get that. Right, they're both what, round? Okay, but what are some of the differences? Right, one's heavier than the other. Right, think it through. Water's heavier than most air. Okay, that makes sense. Okay, what are some other differences? This one I might get wet. This one punctures. This one I won't. Okay, but one of the similarities that comes up, right, is they're both filled with fluids. That's right, you heard it. Right, a liquid and a gas or air. They're both fluids. So what is a fluid? This is the first concept we're going to talk about. A fluid is something, a substance that can flow. So think about it, something that can kind of move through a tube or be poured. So something that can flow. And the second thing is it takes shape of its container. Just like water takes the shape of the balloon. If I were to stick it in an aquarium, right, that's rectangular, or if it's a bowl, it's going to take the shape of that. The same thing happens with air. Right, or other fluids. Okay, so if I were to pour air into a balloon, right, it takes that shape. If I were to pour it into an aquarium that's rectangular, right, it might be a lot harder to see, but it takes the shape of it. That's why I can put it into a cylinder for scuba diving, right? It takes the shape. So again, a fluid is something that flows, right, and something that takes the shape of the container. Let's take a look at a couple different examples to show you some of these fluids. Right, the first example is a raft, or say maybe a water tube. Okay, it's fluid filled, right? It's filled with air or gas. Right, the next one, maybe it's a bucket of water. Right, we've talked about it. Right, if the water can flow into it, it takes the shape. Right, how about a hot tub? Right, it's fluid filled. Or how about a hot air balloon? It's fluid filled. Lots of different shapes. And then one of my favorite, kind of go back to childhood, right? This plastic bear, it's filled with honey. Can honey flow? Absolutely, right? If I have a tube, right, I could pour honey down one side of the tube, it's going to flow through, and then that honey takes a shape. That doesn't mean that honey can't harden and then it stops being a fluid, but you have to think that through. Does it flow, and can it take the shape of that container, whatever it's in? Now that we have a better idea of what is a fluid, let's take a look at the second part. We talked about fluids, and now we're going to talk about what we call pressure. And they do go hand in hand. So pressure, what is it? It is a force over a given area. Right? So we know what a force is, a push or pull. So if I'm pushing on somebody, right, pressure is the amount of force, so maybe it's in newtons, and it's over the area. So maybe I'm pushing them with a finger, or I'm pushing them with a hand. The pressure changes, right? The force didn't change, but the pressure changes because the area changed. So again, it's a force over a given area. Right? And we use pressure a lot, right? Maybe you think of it kind of as a term of like, I'm under a lot of pressure, right? My parents keep trying to make me do this, right? And what's that? Your parents are forcing you to do something, right? They're pushing you to clean your room. They're pushing you to do homework. They're pushing you to, etc. Right? They're forcing you to do something in a given area in a sense. Okay, but looking at scientifically, we have a really kind of cool, equation for it. Right? Pressure equals force divided by the area, or over area. All right. Now, if we're thinking about this kind of the U.S., kind of what are the terms? How do we measure that? Right, in the U.S. we use what? PSI. So pounds per square inch. Right, so again, pounds, right, we talked about that. That's a force, right, because gravity's pulling on mass. So force over the area. Right, so if you're thinking about pounds per, that's the division, per square inch. You might be familiar with this a lot with sports equipment. Right, if you're thinking about a soccer ball, right, you're pumping it up, right, the PSI is about 10 to 15 pounds per square inch, or PSI. Right, if I'm pumping up a bike tire, it depends what it is, right? If it's a mountain bike, maybe it's 30 or 50 PSI, right? If I'm thinking about a road bicycle, it might go over 100 PSI. So again, it's not necessarily saying, hey, there's a ton of force. It's really over the given area, right? Like a road bicycle, the tire's really, really thin versus a mountain bike tire, which is greater. So hopefully that kind of gives you a ballpark. Now, we're not here to talk about PSI. We're here to talk about pascals, right? If you remember Pascal from math class, Mr. Pascal, right? The Pascal's triangle, or the Pascal's law. Okay, we're talking about the science. So pascals is our measurement or our units for pressure, or it's capital P and a lowercase a. A lot of times we use kilopascals, which are basically, remember the metric unit, 1,000 pascals equals a kilopascal. And we use that because pascals are pretty small. So depending on what type of science you're doing, yeah, you might use different metric units, but for our general purpose, we're probably going to be using kilopascals. Okay, so say I were to go back to that soccer ball example, right? So I said PSI about 10 to 15, right? That's the pressure. What would that be in pascals? We're looking about 80 to 95 kilopascals. So again, a pascal is really small for saying 80 to 95 kilopascals, right? So that's a lot. Again, if I'm talking about NFL football, it's about 12.5 to about 13.5 PSI. Unless you're Tom Brady, I think it's a lot less, right? But if I'm talking about kilopascals, right, that's going to be about 86 to 93. Okay, if I'm looking about, here's an interesting one, a plane cabin. So, right, we're inside an airplane, right? It's like the cabin pressure is, if we're looking at PSI, this is kind of funny, it's 11 PSI. So we're kind of like a soccer ball. We're inside the soccer ball when we're in a plane cabin. If we're looking at the kilopascals, kind of the units, again, in science, we're looking at about 75 kilopascals. This is a unique one. How about a pressure washer, right? So maybe you've seen people use it to kind of clean the side of their house or maybe the sidewalk, right? What does it do? It's forcing water out of the end of this pressure washer, right? In PSI, we're looking at about 2,500. So kilopascals, this number gets crazy. We're at about 18,000 kilopascals, right? So you might not love the big numbers, but that's typically where the science community, that's what they use, is kilopascals and pascals. And then, again, they can use other prefixes according to the metric unit. Now let's take a look at two different problems here. So say we have an aquarium, right? We know that the aquarium has about 5,000 newtons of force being applied to the walls of the aquarium, right? This is important. If you've ever watched any of the shows where they build these custom aquariums, right, it's super important that they get the correct amount of pressure that the aquarium can hold so it doesn't just burst. So say we have 5,000 newtons of force on the outsides of it. Okay, we measure the area, okay, and say for example we have 10 square meters. Okay, so 10 meters squared, right? The equation we go back to, right? Pressure equals force over area, right? Force is in newtons, so we have 5,000 newtons divided by, we have square meters. Okay, so we're using 10, so 5,000 divided by 10 is 500 pascals. Okay, if you were to put that in kilopascals again, we put it as 0.5 kPa, okay, short for kilopascals. Okay, so hopefully that helps kind of show you kind of a real life example. Another one might be, say we have a compressed tank. All right, so say maybe you've seen people carry around these oxygen tanks, or maybe a scuba diver, they have a tank. Welders have tanks. So say we have a compressed tank. That just means compressed, right? We have pressure, right? Compression. And say we have 600 newtons. So the force pushing on the inside of the tank is 600 newtons. And if we were to measure it, it was 2 meters squared. Okay, how much pressure would it be? So 600 newtons divided by our 2 meters squared, and we end up getting 300 pascals, or 0.3 kPa. Just a quick way to show you how these problems were used to figure out how much pressure there is. Obviously, if we had a tank, right, and we made it even larger, okay, there's going to be less pressure. If we had a bigger aquarium and the same amount of force, right, there's going to be less pressure. Now that we've covered fluids and what is pressure, hopefully you join us for our next video as we take it to the next level. We learn more about fluids, the fluids that are around us. So more than just, hey, what's the fluid inside that tank? What's the fluid inside that soccer ball? And how much pressure can they hold? So keep in mind what you learned today. Hopefully you can join us for our next video as we start talking about atmospheric and oceanic pressure. Thanks for watching.